In this video, I will be going to discuss about one of the sorting technique which is called merge sort. There are two ways of merge sort. First is recursive, second is iterative. In iterative, we use for and while loop and solve the problem. While in recursive, we call the function in itself by that function call. So time complexity of merge sort is in worst case scenario is big of n log n. In best case scenario also big of n log n. Space complexity is big of n. It is not an in-place algorithm because there are two separate arrays are there and we sort them and after that we merge them. It is also divide and conquer problem. We first divide the two arrays, then sort them, we split them, then sort them and then merge them recursively. So that's the case. It is a stable algorithm, means the first element, the copied element which is first come get the first seed and the last come get the last seed. It is well suited for linked list because in linked list we have pointers, so that's why we know the each and every element's address so that we can easily put that element into particular order. So it is take only big of one auxiliary space in case of a linked list. It is used in external sorting. Why? Because we merge two separate arrays. Likewise, we can, if we have two separate files and we want to sort them in the basis of increasing or decreasing order, we can sort them and after sorting them we can merge them. Also in optimization merge sort, which is called as block merge sort, it takes only big of n log n time as previously take big of n log n time. And the X factor is that it is also in place algorithm, means it doesn't take extra space. While in normal recursive merge sort it takes extra space. That's why it is optimization version. So let's try to code it. First we have to take the merge function which can merge our two arrays after sorting them. So we have to write that function first. We have to take low, we have to take mid, we have to take high. So these four parameters represent, first is array, we take array. Then second parameter is low. Low means the indexed, low index. Mid means middle index, and high means higher index, which is the end point of that particular array. Then we have to assign I is equal to low, then j is equal to mid, and k is equal to low. Then instead of taking two auxiliary arrays and like split them into two half, we take a one auxiliary array and try to sort that array beforehand, and after sorting that array we can just copy that auxiliary array into the our main parameter array. So that's why I here taking array of size 100. Instead of taking two separate array, I am taking the one array. And after that we have to take while condition, because if I is less than equal to mid and j is less than equal to high. Why these two condition? Because we have to split the arrays, we have to take splitted format arrays. So first pointer, so sorry, first index first go from 0 to mid, and the second index j goes from mid plus 1 to high. So there are two index and two different sorting are there. They recursively sort every split and then merge that. So that's why we here use merge function. And we have to use condition that array of I means first array of any element of that first array is less than the second the second array of any element. Then we have to just copy those element into the first array, which is our third array, means b of k, which is my auxiliary array. And if this condition is false, then we have to store array of j plus plus, means we have to store second array into the first array. For example, in first array there are three elements 1, 2, 3, and in second array there are three elements 4, 5, 6. Then first array of first index, that is 1, is compared with the next array first element, that is 1 is compared with 4. 1 is always less than 4, then 1 should take place into the third array. Likewise, if this condition false, we have to put our another array element into the third array, and afterwards, means after finishing this, the remaining element we have to store those remaining elements into third array. So this first remaining array elements are stored into the B auxiliary array. Then again j less than equal to high. Then again remaining elements of second array we have to store in auxiliary array likewise. And at last, after completing all the merging, we have to shift that auxiliary array into our parameter array, which we take as a parameter because we have to return that. It is void function, but it is passed by reference, so automatically all the elements which are sorted in the auxiliary array come into the array arr, that variable. That array will take all the elements, so that's why we have to take I is equal to low, I less than high, I plus plus, and then we have to shift all the array elements into our return parameter, which is array. We have to store auxiliary elements into the array, and that's it. This is a merge function. So we have to write merge sort function also. We have to sort this array. This also take three parameters. First is array itself, then high, then low. And in this case we have to define mid, and if low is less than high, we have to call recursively merge sort function again. That's it. Array low comma mid array mid plus 1 comma high. So mid is used for splitting the array into two equal halves. So in first recursive call, our high is our mid, because we have to go to the middle part of that particular array. And in second recursive call, our low is our mid plus 1, because we have to start from the mid and then go up till high, that is high index, that is last index. And again we have to merge this by using merge function, because we already sorted that. We have to merge them. So low comma mid comma high. So that's it. This this works well. So we have to check it by using some sample elements. So 5 1 2 0 8 1. So there are 6 elements. So we have to call merge sort function, pass the array, low is 0, and there are 0 1 2 3 4 5 index, last index is 5. So we have to pass that, and after calling this function we have to show the elements. So that's why using cout function. So that's it, code is ready. We have to check again if anything is wrong in the code or any syntax error or anything. So let's run the code. So as you see on the screen, the array is sorted successfully, means our function is work well. That is recursive merge sort. 0, 1, 2, 6, 7, 8. The numbers are in increasing order. So that's it. Thank you for all. Stay blessed.